Hi everyone. Today what we are going to deal with the topics called stopping distance and reaction time. So first of all, let's discuss about what is meant by stopping distance. So see the definition here for the stopping distance. Stopping distance is the distance required to stop a moving object when retarding force is applied. Right? So just an example, when an object is now in motion, for example, a car is driving by a person. When the person is apply the brake, do you think the car will stop suddenly? No. Just to see an example in this case. The driver apply the brake. The car is not suddenly stopped. It is moving little bit. That means even after apply the brake, the distance traveled by the car, in this case we can consider as what? Stopping distance. So what is the meaning? Even after apply the brake, the car is not stopping suddenly. Some more distance it is traveling, and that distance traveled after applying the brake, and that is called what? Stopping distance. So now let's derive the relation between the stopping distance and the speed. So what is the relation between stopping distance and the speed of the object? Let's see an example. A car is now moving with a velocity u. Say it as the initial speed as u. Suddenly the driver apply the brake. Just imagine the car was traveling with a velocity u. Suddenly the car driver applies the brake, and you see here the distance traveled is x, right? The distance traveled here x after applying the brake. So we can consider here the distance traveled after applying the brake, x is equal to the d. Say it as the stopping distance d. Now after applying the brake, definitely the car will come to rest, correct? So we can say it as the final velocity of the car is equal to 0. The final velocity of the car is equal to 0. Now we can use our equations of motion. We can use the formula here. V square is equal to u square plus 2ax. Here what is the velocity? Final velocity. Final velocity is equal to 0. Which is equal to, what is initial velocity of the car? It was coming with an initial velocity, right? So that is equal to u square. Now what is actually happened to the car? Is it accelerating or decelerating? Decelerating. So we can write here acceleration is negative because it is retardation, right? So now we can write here minus 2a into x. Here what we have written here, x is equal to ds, that is a stopping distance. So 2a into ds. So we can write the equation as 2a ds is equal to u square, or d subscript s, that is a stopping distance, which is equal to u square divided by 2a. Imagine the retarding force is constant. That means the person is applying the brake, is applying same force. So what will happen? The acceleration or the deceleration become constant. So in this case, you can write this equation. Stopping distance is directly proportional to the initial speed square of the initial speed. So this is the relation between stopping distance and the initial speed of the object. So stopping distance depends upon what? The initial speed. If the initial speed is much higher, what may happen? The stopping distance also will be more. In practical situation, may cause an accident in the road, right? So stopping distance is directly proportional to u square. Now let's do an example question here. If s is the distance in which a car can be stopped by applying full brake, Full brake means definitely the person is applying a constant force. When it is moving with a speed v, correct? What is the distance in which it can be stopped by the same retarding force when it is moving with a speed 2v? So we can use the formula here in this case. What is the stopping distance formula? ds is directly proportional to square of the initial speed. Here what is the first case we can write here? ds1, right? Stopping distance, first one, is directly proportional to v square. The initial velocity is given, the speed is given the v. Now what is actually happening here? When the initial speed become doubled, it become 2v. So we can write here the stopping distance as ds2 is directly proportional to 2v all square. So this is equation number 1. So we can write here ds2 is directly proportional to 4v square, equation number 2. If you divide the equation number 2 by 1, we can write here equation number 2 divided by 1. We will be getting here ds2 divided by ds1 is equal to 4v square divided by v square. So what is the stopping distance when the speed doubled? ds2 is equal to ds1 into 4. What is the meaning here? The stopping distance become increased to 4 times, right? The initial stopping distance was ds1, now it is increased to 4 times of the initial stopping distance. That means doubling the speed, it will increase the stopping distance comparatively the first case. So this is an example question related to stopping distance. Now let's discuss about what is meant by reaction time. What is meant by reaction time? It is the time a person takes to react to an incident. What is the meaning here? If something happens suddenly, right? If a person sees a snake suddenly, if the person is standing there itself, what may happen? May the snake bite. When a person sees a snake, suddenly he observe and he think. What he is thinking? He has to act and he has to move back, right? So suddenly he has to act. So this is an example for what? Reaction time. So time a person takes to react to an incident. One more example, if you see this picture, you see a person is now catching ball in the slip. See, the person observe the ball is coming so fast. He observe and think, suddenly he acted. That means his reaction time is too small. Just imagine his reaction time is more. He is observing and he is thinking and he is acting slowly. What may happen? The ball may reach at the boundary, right? So in this case, his reaction time is very, very small. So he could catch the ball, right? So reaction time means what? Reaction time is a time a person takes to react to an incident, right? Now there is an example question given there in the NCERT, example 3.8. You can measure your reaction time, right, by a simple experiment. Take a ruler and ask your friend to drop it vertically through the gap between your thumb and forefinger. After you catch it, find the distance d traveled by the ruler. So in one of the example is given in a particular case, d was found to be 21 centimeter. Estimate the reaction time. Estimate the reaction time. So in this case, the ruler is now at rest. So we can say here the initial speed u is equal to 0. That means initial velocity is equal to 0, right? Now when the ruler is now dropped by the first person and suddenly the second person has to think, has to observe, has to think and has to act suddenly, right? Just imagine the distance the ruler is traveling, right? The distance the ruler is traveling. After that distance traveled only the person is holding the ruler. So how much distance it is traveling? In the question it is given the d is equal to 21 centimeter. D is equal to 21 centimeter, the distance it traveled vertically. Or we can write here using sign convention, D can be written as minus 0.21 meter. Why we have taken minus here? Minus we have taken here because it is coming vertically downward. Okay, so we have already discussed in the sign convention, moving up can be taken as positive and vertically coming downward we can take as negative. Now we use the formula in this case. S is equal to ut minus half gt square, right? Here this t represents what? The reaction time. Okay, here also we can write the reaction time. But here initial speed is equal to u, so what we can write here? S is the vertical distance traveled by the ruler. That is given the minus d, which is equal to minus half gt square. T represents here what? Reaction time, so it is written the t subscript r. Minus minus will cancel, so we can write here 2d is equal to gtr square. So we can write the reaction time is equal to root of 2d divided by g. Root of 2d divided by g. Now here the distance traveled is given the 21 centimeter. That means after 21 centimeter only he could hold the ruler, right? So that is a distance is traveled just before he acted. So we can substitute here and the reaction time can be calculated as 2 into 0.21 meter, that is 21 centimeter into meter, divided by g value. What is the g value? 9.8 meter per second square. So what is the reaction time of this person? In this example it is given the, if you calculate this value you will be getting approximately 0.2 second. Alright, so his reaction time is 0.2 second. Just imagine his reaction time is 0.1 second. So what may happen? This much distance it won't travel. Okay, so this is the reaction time of this person as an example. I hope you understood this topic. Thank you all of you.